Okay, resolving vectors. You write the title. Okay. Continue. You have the title. Okay, so horizontal and vertical vectors. You know these words? This is horizontal and this is vertical. Horizontal and vertical vectors can be added together, just like any two vectors. But this is actually very common in mechanics. And so is the reverse. If you have a vector and you want to know the original horizontal and vertical. So in other words, just to give you an explanation here, you have a horizontal vector and a vertical vector, and you add it together, and what's this one called? Resultant vector. What we want to do today is to take a resultant vector and to write it as a horizontal plus a vertical. The verb for this is resolve. So that's what it means to resolve. It means to take it back to the horizontal and the vertical. Okay? You might want to write that down if you didn't know this word, resolve. So resolve means to find the horizontal and the vertical parts of the vector. Whereas this one is just simply to add. So a horizontal plus a vertical equals a resultant.
What's resolve again?
It's the opposite. You have the result and you want the original horizontal and vertical. So you have the result and you want the A and the B. So let's have a look at that. Can I continue? Yeah. Right, so we were talking a few minutes ago about Pythagoras. You all know Pythagoras, nothing very special. When you have a right angle triangle, a squared equals b squared plus c squared. What you might not know, depending on your language, is the name of this. So this is called Pythagoras. So if you didn't know his name, please write it down, Pythagoras. Now, even if you're an Arabic speaker, I still think Pythagoras in Arabic is still Pythagoras. So it's his name, so it shouldn't be different. Although I think in Chinese, Japanese, and Korean, Pythagoras is a different name when you translate it. What is it for you? What's your first language? Chinese. So it's something like Gogodi or something. What's his name in Chinese? Do you know it? You don't know his Chinese name? You forgot it, yeah. I know in Chinese it's not Pythagoras. His name is something else. I don't know. I can't even say. It's something like Gogodi or something. But in Arabic, it's still Pythagoras is his name. Okay. So you can use Pythagoras to calculate the magnitude, how long it is. Now, the next thing we need so here's a very, very simple question. I want everybody to do this for me. What is the magnitude of the resultant of 3 meters east and 4 meters north? And some of you might already know the answer, but if you can just write it down. I want the magnitude of the result. So you have 3 meters east, 4 meters north, and I want the magnitude of the result. I think it will take you like 10 seconds to do. You know the answer? Yep. So it's 3 meters east, like this, and then 4 meters north, and I want this one, and this is right angle.
5 meters.
5 meters, yeah. X squared equals 3 squared plus 4 squared. X squared equals 25. X equals 5. Okay? But like I said, some of you probably knew that already because you have the triangle 3, 4, 5. And what's the other famous triangle? 5, 12. Oh no, you don't know this one? Not this one? You have a 3, 4, 5 triangle, and the other one is 5, 12, 13. You don't know that? You haven't seen this one? Oh, okay. Anyways, a little bit of vocabulary. You want to write these names down. So, in a triangle, this side is called the opposite because it's the opposite of the angle, obviously. The longest side is called the hypotenuse, and the other side, which is beside the angle, is called adjacent. In English, adjacent means neighbour. So it's like saying this is the neighbour of the angle, this is the opposite of the angle, and this one there is the hypotenuse, the longest side. Okay, so these might be new words. Just in case, can you draw this triangle? Write its names down. Even if you know the names, it's good for your spelling to write them down again. Are these new words, or you know these words? Yeah, that's that one, yeah. Which is the name of the slide. See? Yeah. Okay, so we have this thing called, you see, in maths class we'll talk more about this. This isn't really for physics class, but it's something I'm sure you probably already know. But I'm not going to talk about it too much. This is more for maths class. But if we have a triangle, and we know this side, which is the opposite, and this side, which is the adjacent, and we want this angle, we have a function on our calculator to calculate this. To calculate the angle, which is the direction, it's tan inverse opposite over adjacent. Now, you might say, what is tan inverse? This is something we're going to talk about in maths. For physics, for right now, we're just going to use our calculator. So we press shift tan opposite over adjacent, and the answer will be the angle. Okay, but I'm sure you've done this many times before in maths class. So we can use tan inverse opposite over adjacent to find the angle. Okay. That is the theta. So you just please make note of this. Theta equals tan inverse opposite over adjacent.
But then what if they gave us like the other side or something?
Highly unusual. I've never seen that happen. You could use Pythagoras to get the missing side.
So like can't we use like so?
Yeah, we'll talk about sine and cos in a moment. Yeah. Okay. Theta equals tan inverse opposite over adjacent. Right. Try this for me. You'll need your calculator. If you don't have a calculator, you can use the one on your phone. This time, I want the angle, the direction.
Direction?
Yeah, the angle. Sounds about right. Okay, let's have a look. So, if this side was 3 and this side was 4, then theta would be tan inverse 4 over 3, which is 53.1 degrees. Okay, that's okay? Yeah. Right. So now we're going to talk a little bit about sine and cos. So I have this diagram to show you the 3 formulas. Again, I really expect students to have done this before, but as a revision, we say sine of theta is the opposite divided by the hypotenuse, cos of theta is the adjacent divided by the hypotenuse, and finally the one we've done a moment ago, tan of theta is opposite divided by adjacent. So can you please make note of these? So this is called Sohcahtoa. Okay, so normally what happens with these questions is that you know the magnitude and you know the direction. That's the typical situation. And basically we want to know the opposite and the adjacent. So we can use sine, cos and tan to resolve it. And let me show you how. So what happens in these questions is normally you know what the magnitude is, so let me just call that or, and normally you know what the angle is, let me call that theta. And what you want is to know this magnitude, which is x, and then this magnitude, which is y. So here's how you can do it. You can say sine theta equals y over or, opposite over hypotenuse. And what would cos theta equal? X over r. So therefore, x equals or cos theta, and y would equal or sine theta. So in other words, if you have the or and you have the theta, this side would be or cos theta, and this side would be or sine theta. So because you know the or and the theta, you can easily get the other two sides on your calculator by using or cos and or sine. Now, sometimes what happens, I'll go back to this in a moment later, sometimes what happens is in the exam you have some very complicated picture and there's stuff going on, and they give you like an angle here maybe, and you're thinking, oh my goodness, how do I figure out which is the cos, which is the sine? So I'll give you a little trick. It works every time. The trick is this. The side which touches the angle is always the cos. So in this diagram, you see this side? It touches the theta. So this is going to be or cos theta, and this side therefore is or sine theta. So the trick is if you touch theta, that makes you the cosine, and so the other side then, that has to be then the sine. So you can see that here. This side touches theta, so it is going to be or cos. This one here then has to be or sine. So this is how we can resolve. This is how to resolve. This is very, very useful. We'll use this a lot. So if you can carefully write this one down now. And I'll do an example in a moment, of course.
I'm not sure about this because I haven't done it in a long time, but when we switch it to the other side, doesn't it have to be like inverted cosine or?
Yes, no. I know what you mean. We only use the inverse of cosine or tan whenever we want angles. But if we're not looking for angles, we don't use the inverse of sine and cos. So here I'm looking for lengths. So I shouldn't have the sine or cos. Now, what's happened here is I've brought the or up. So there was no, I never brought the sine or cos to the other side. I know when I wrote it down here, I wrote it on the other side. But if you prefer, you can just write the x and the y on the right, if this makes you a little happier. So the cos and sine never moved sides.
But if they do move, then they're going to be inverted.
Usually,
so that's to find the angle.
Yeah, when we need to move a cos to the other side to find the angle, it becomes an inverse.
Could you repeat the second part though?
Which part?
The one where
the trick?
Yeah.
Yeah, the trick is whenever the component touches the angle, that makes it the cosine, and therefore the other has to be the sine. So, you know, if I have...
So it's like three lines?
Yeah, let's say we have a vector here.
Okay.
And let's say this is theta, and I want the horizontal, and I want the vertical. And we call this one is or. So, because this one touches the theta, I automatically know this will be or cos theta.
Okay.
And that one has to be or sine theta. The reason I'm telling you this trick is so that in the exam, you don't need to draw a triangle to figure out every time what each one is. You know what I mean? We can just use this quick trick to get in the sides. So this one is or cos, and therefore this one is or sine. You get what I mean by the trick, yeah?
Yeah.
You just need to check which one touches the theta, and that's the cos one. Okay, can I continue with the slides? Right, so before we do an example, a little bit of a definition. Speed is the magnitude of velocity. So, if I give you a velocity vector, like for example, let's say this one here, this is 5 meters per second, and let's say this is 3 meters per second, and this is 4 meters per second. The speed is this part, the magnitude of the vector. So for example here, the velocity is 5 meters per second at 53.1 degrees. Earlier we worked out that this is 53.1. You remember that? But the speed is the magnitude which is just how long. So that would just be 5, no direction. So in other words, speed is the magnitude of the velocity vector. But you kind of know this already, because speed is a scalar and velocity is a vector. Okay. Continue. Right. So we have 2 examples. I think I'll let you try it, and then I'll do it. So the first one is 10 meters per second horizontally along the ground and 20 meters per second vertically upwards. What is the magnitude and direction of this vector? So it's 10 and 20. What's the magnitude and the direction, the angle? You need your calculator?
Yeah.
Here, can borrow this. Finished?
Yes.
Yeah.
Thank you.
Okay. So let's have a look. It's 10 meters this way and 20 meters this way. Part 1, what's the magnitude? So what do I use to get the magnitude? Pythagoras. X squared equals 100 plus 400. X squared is 500, so x is square root 500. 52.36. Square root is 22.36 meters. That's the magnitude. Now time for the direction, the theta. So theta is tan inverse 20 over 10, which works out to be 63.4 degrees. Magnitude, direction. Yeah, easy peasy. Yeah, okay, next one. Lemon squeezy. Okay, next one. Right. So this one's a bit different. This time I give you the direction. This time I give you the magnitude and the direction, and then I want you to resolve into the east and the north, the horizontal and the vertical. So this is the opposite now. You'll have to use the or cos or sine example that I gave you. Do you remember what baron of 30 is? You might have to check your notes. Yeah, that's it. Yeah, that's it. Got it? Yeah. You have this? Yep, let's have a look. 15 kilometers an hour, bearing 30. So I'll just draw my compass here. North, south, east, west. So bearing is like this, 30 degrees from the north, and it's 15 kilometers per 15 kilometers per hour. So which one is this, cos or sine? No, sine, because this one is cos. So this one will be 15 cos 30, and this one here, 15 sine 30. So 15 sine 30 is 7.5 kilometers per hour, and this side is 15 cos 30, which is 13 kilometers per hour. So the two answers are 13 kilometers per hour north and 7.5 kilometers per hour east. And if you want, you can write that down. So you can say 15 kilometers per hour at bearing of 30 degrees. That's equal to 7.5 7.5 kilometers per hour east plus 13 kilometers per hour north. If you don't need to, if you want to, you can. Okay, that's okay. Yes, yeah. This. You'll do this a lot in physics. It's a very common thing to do in physics. Okay, continue. Yes. Okay, so this is the homework, which you can start it now for a few minutes. Might even get it finished before you have to go home. But if you don't get it finished, finish it at home. Okay, so this is the homework here. Nader, how come no homework from last night? What happened?
When I go to Moodle, actually I didn't know how to enter the Moodle.
Did you email me?
No.
Okay, alright. Did you take a picture on your phone?
I took a picture actually, but I forget about it.
Okay. If you want, you can take a picture of this one now. Yes.
Actually, can you show me this? How we can go into this?
Yeah, the username is your email address, and the password is your date of birth. So, for example, it could be something like john@gmail.com. That's the name, and the password could be like the 1st of January 2000. And the website is difcmoodle.ie. Now, I have to make the account for you and for you. So your account will be made. I usually make accounts on Thursdays because the reason is I make one day a week when I make everyone's account. So that means on Friday it should work for you to log in. So the website that you go to is difcmoodle.ie, and it's the email you give on registration and your date of birth, day/month/year is the password then. Yeah? Okay.
In question 3,
Mm-hmm.
northeast is equal to 45 degrees.
Yep, yep.